Welcome back for another chemistry lesson. Today, we're going to be talking about molar identities and how to use them. So there are 3 molar identities that you need to be familiar with. The first one is the number of atoms or molecules that are in 1 mole of a substance, which is 6.02 times 10 to the 23rd power. This is called Avogadro's number. That may be a term that you've heard. If you haven't heard it yet, you will be hearing it. All right, secondly is the fact that at standard temperature and pressure, 1 mole of a gas has the volume of 22.4 liters. Again, this is only for gases and only at standard temperature and pressure. And then finally, 1 mole of any substance is equal to whatever the molar mass is, grams of that substance. So just like any other identity that we may know, like 1 foot is equal to 12 inches, for example, we can use these identities as conversion factors. All we have to do is rewrite it in the format that is useful to us. So it could be moles over grams, or it could be grams over moles, for example. So here you see all of the potential ways that we can arrange that. And I have X in here because depending on what your substance is, the number of grams will differ, and you'll have to calculate the molar mass for that. So we can use this in any kind of conversion problem. I have given a few examples here that we're going to work through so that you can see how we use that kind of identity. All right, so question number 1 is how many atoms are in 6.14 moles of iron. When you're doing a conversion factor, a conversion question, the first thing you should do is write down what you're given. So I am given 6.14 moles of Fe, and I want to know how many atoms are in that. All right. I will need a conversion factor, and whatever unit is on the top here, in order for it to cancel out, that unit will have to be on the bottom here. So if I'm looking for atoms, I'm going to want to look for the conversion factor that has moles and atoms in it. And specifically, because of what I said down here, I want the one that has moles on the bottom. So I'm going to pick this. Avogadro's number does not change no matter what substance you're working with. If I'm talking about a mole, I'm talking about that many atoms or that many molecules. So 6.02 times 10 to the 23rd. And that's atoms of Fe in 1 mole of Fe. And then I just plug it into my calculator. So reminder about how to plug in a calculator like this. Everything across the top goes in one set of parentheses, everything on the bottom, and divide. So what that would look like in a calculator would be 6.4 times 6.02 times 10 to the 23rd. Please be careful with your scientific notation when you type it in the calculator. Divided by 1. Again, there's that bottom number. There's everything that's on the top. So the answer that I get for this problem is 3.696 times 10 to the 24th atoms of iron. All right, the next question. How many moles are in 38.6 liters of oxygen gas? I did not type it out here, but we're assuming standard temperature and pressure for this. So I'm going to write down what I'm given. And I know I'm going to have a conversion factor in there. Now I'm looking for the conversion factor that has moles and liters in it. And because liters is on the top here, liters is going to have to be on the bottom down here to cancel. So I want that conversion factor. So 1 mole occupies 22.4 liters, and this is oxygen gas we're talking about. So everything on the top multiplied together, divided by everything on the bottom multiplied together, and I get 1.72 moles of oxygen gas. And now the final question for the third type, I have how many moles are in 48.7 grams of sodium. Okay, if you are not familiar with how to calculate the molar mass, this I've done just for an element, but I'm going to put a link up in the cards right here for my video on calculating molar mass if you need help with that. But you're going to have to be able to get your molar mass. So in this case, it's sodium. I've got 48.7 grams of sodium. Again, we have grams of sodium on top, so grams of sodium is going to have to be on the bottom. And grams is going to have to be on the bottom, so I'm going to grab that conversion factor right there. All right, so 1 mole of sodium, according to the periodic table, 22.99 grams of sodium. Plug it in, and I get 2.12 moles of sodium. All right, now we can also do a multi-step, more complex problem. And this is where we can come into and out of our standard stoichiometry problems, which you may or may not have covered at the point where you are watching this video. But this is a way that we can build into it and use multiple conversion factors. Okay, so I'm looking at molecules and liters. Right? If I go up here, there is no conversion factor that has molecules and liters in it. However, every single one of these has one common factor in it, and that is the number of moles. So if we can get into moles from one unit, we can then get out of moles to another unit. All right? So that is what we're going to be doing here. So I'm starting with 41.9 liters of nitrogen gas. Again, assuming standard temperature and pressure. I have to get into moles, and then I can go from moles to molecules. All right? Because liters of nitrogen is on top here, liters of nitrogen has to be on bottom here to cancel out. So that's that 22.4 liters in 1 mole of nitrogen. All right, so my liters are canceling. Now that I'm in moles, I know that there are 6.02 times 10 to the 23rd molecules in 1 mole. So moles will go on the bottom because, like we said before, in order to cancel out, they got to be on opposite sides of that line. And 6.02 times 10 to the 23rd. Molecules of nitrogen. All right, my moles will cancel out, and I'm left with molecules, which is what I wanted to begin with. All right, so I plug that in my calculator, and I get 1.13 times 10 to the 24th molecules of nitrogen gas. And one more final question. How many grams do 6.94 times 10 to the 22nd atoms of potassium weigh? Again, I'm not going to have a conversion factor up there that goes directly from one to the other, but I can go through moles. Moles are the common area. If you can get to the common area, you can go wherever you want to go, right? So, write down what I'm given. So that's atoms of potassium. All right, I know that there are 6.02 times 10 to the 23rd atoms in a mole. And the atoms have to go on the bottom so that they will cancel out. All right, so again, that one's on top, therefore that's got to be on bottom. And now they'll cancel out. All right, now I'm in moles. I can go from moles to grams. Right, so like we talked about before, if moles is on top, moles will have to be on the bottom. So 1 mole of potassium equals molar mass. Again, go back to that video I previously put in the cards to figure out how to do molar mass, but that's 39.098 grams of potassium. Now my moles will cancel, and I'm left with grams, which is what we wanted. So plug that in the calculator, and I get 4.51 grams of potassium. So don't think of this as being some new scary thing. If you've already done unit conversions, this is exactly the same as unit conversions. We have it set up with these specific conversions here that will be helpful to your work. And that's it for using your molar identities.